Today we shall discuss about the STAAD Pro software. We will create some model and we shall apply some properties and support condition and load, and we will analyze the structure. Okay, and you can see the result of the analysis of the structure. So let us start. Let us consider a beam, a simply supported beam, cantilever beam, subjected to a point load at the free end. So first of all, what we have to do, you have to go to the grid option and click the beam grid. Then you can see this is the grid, by default grid, and the plane in XY plane the grid is present. Okay, the grid is present, lies on the XY plane. So we have to create the grid that we need. So go to create and here select the irregular one. We have three options: linear, radial and irregular. So we don't need linear or radial. So select the irregular. Now give any name, whatever it is. You can type anything. So let me type cantilever beam. Okay. Now choose the plane. So XZ plane I will choose, and the length of the beam will be say 4 meter. So and along the x axis. So now the relative guideline distance, first distance would be 0, and then you have to give the space, and then you have to give the another measurement, that is 4. We don't need in any dimension in z direction because we have only one beam here. That's why we are applying the x value only. Now click on OK. Now you can see our irregular grid system is created, and just check the irregular grid system and you can see the grid line. Okay, so here you can see the 0 and 4, that is 4 meter distance. Now you can see the cursor is here like a cross. Now you just click on the node. This end point of the beam is called a node. Okay, so click here and then click here. Now our beam is ready. Now if you uncheck the irregular grid system, you can see this is the beam. So press escape or press geometry so that you can get out from this geometry pane. From this right side pane you can see the XYZ value of the point. Here this is 0, 0, 0, and here it is 4, 0, 0. The x distance is 4 and y and z distance is 0. Now this is the simple line. This is not a beam actually, this is simple line. Okay, so I want to show you one thing. Go to view and here it is 3D rendering. If you click on 3D rendering, you can see this is a line only. This is a line only. Okay, so first of all you have the length of the beam. Now you have to apply some properties. So click on properties. Now here you can see the properties pane will open. Now you click the define command here. define. Once you click define, you can see the property dialog box will open, and you can see the some shape is there. The rectangle one I want to choose. So under this option rectangle, you see ZD and YD is here. ZD means width of the beam and YD means depth of the beam. So YD, that is depth of the beam. Let us consider depth of the beam is 0.3 meter. Okay, here you can see FT, that means feet. It is a problem of the software that it will show the feet here instead of meter. So don't worry, the all calculation will be done with the help of unit meter. Okay, so don't think about the unit that is showing here, it is wrong. It will be meter. So ZD, that is width of the beam. Let us consider width of the beam. Okay, so let us consider width of the beam is 0.3 and depth of the beam say 0.5 meter. Okay, now you can see the material list is also here, and it is selected by default. It is concrete. Okay, now you have to click on add. Just click on add and click on close. You can see the section is added here, and now what you have to do, you have to assign this section on the beam. So what is the assignment method? Here you can see the assignment method, and you have 4 options. One is inactive because it is not selected. Once you select it, then it is also will be activated. So that is 4 option, and use cursor to assign is here, to use this cursor to assign the beam. And if when you are going to model, when to create a model, you can face a number of structure. Okay, 100 or 200 number of structure, then it is not possible to assign using use cursor to assign method. So then you can choose the assign to selected beam or assign to view. Okay, then you have to choose. So there is only one beam, that's why I am using this option, use cursor to assign. So click on assign. Okay, now you can see the cursor is changed, and just click on the beam, and this beam is assigned with the section. Now click on the assigning button again. So in the material you can see by default it is concrete, that's why it is showing that it is concrete. Okay, now what we have to do, you have to apply the support condition. So your beam is a cantilever beam, that's why at the one end it will be free and the other end it will be fixed. Okay, so first of all create the support. Now click on the create option, and by default the fixed tab is selected, and you don't need to click on anything. So you can see that all are restrained, fx, fy, fz, my, mx, mz, all are restrained. So just click on add button. Okay, so this support condition is there. This is fixed support, and now you have to assign this fixed support on the node. So you can see the cursor is also changed to a node cursor. Now click on the assign, and you can see the fixed support figure here. This is the fixed support. Now click on that point so that this node is assigned with the fixed support. Okay, now click on assigning again. Okay, fine. So this is the cantilever beam with one end fixed, another end free. Now if you click on 3D rendering, then you can see the beam. Okay, you can see the beam, but you can't see the support. Okay, fixed support you can't see, you can see only the structure, no support. Now go to the loading option. To apply the load, you have to click on loading option. So here the option is load case details. You have to choose, you have to select the load case details and then click on add button. Now you can see there is a different kind of load types: primary load, auto load combination, defined load, all are there. So for building for any other complicated structure, you may need all those options, but now you need only the primary. Now this number will automatically changed, don't need to do anything. Okay, now you just change the loading type to dead load. Okay, and give a title here. Whatever you can type, it will show in the right side pane to understand yourself. So I am typing dead load. Now click on add and click on close. So this is a basket of dead load. Okay, all dead loads will be there. So select the dead load, click on add option, and I want to apply the point load only. Okay, at the free end. So at the point means at the end point, and in the end point is called node. In the STAAD Pro, the end point is called node. So we have to click on the nodal load. Okay, so you can see you can apply the load in any one direction, x, y, z, or you can apply any moment also. So we don't need any moment, we need only load, and it is also a y direction, because you can see the y direction is the y axis is the vertical axis. So we need a vertical downward load. Okay, so vertically means you have to choose fy. You have to choose fy, and don't go through the unit. It is also the problem of this software. So fy you have to choose. Say the load value is 20 kilonewton. Okay, load value is 20 kilonewton. Now if you apply the 20, then STAAD Pro will understand that it is a upward direction. The load direction will be upward. That means positive y axis is the direction of the load. So actually our load is that our load is applying in the downward direction. So to understand the downward direction, you have to apply the minus sign also. Okay, so minus sign will indicate the downward direction and plus sign will indicate the upward direction, and put the value here. And now click on the add button. Click on add button. Okay, and now close it. So at minus y direction, that means translational and or linear y direction, and minus means downward. 20 is the value of the load, and this is the unit. Okay, so here you can see a red question mark is here. That means it is not assigned yet. Okay, you have to assign this load. So select the beam, select the load, and now select the use cursor to assign. It is already selected, and now click on the assign button. Okay, now click on this node. Once you click this node, you can see the load is applied and the red color question marks has gone. Okay, now click on the assigning. So this is our cantilever beam with point load 20 kilonewton at the free end. Now this is our model, and now we have to analyze. So before analysis, we have to define some command. Now click on the analysis and design from this option, or you can see here also this option is a analysis. Once you click on the analysis, this is the same. Okay, so now you have to click on the define command. Click on the define command, and here you don't do anything, just click on the static check, or you can click on no print, no issue, just selecting the static check only. So it will check the structure, whether there is any error or not. It will check only. So this is the static check. Click on add and click on close. Okay, up to that, structure will, if you click on the run analysis, then structure will perform the analysis, but it will not show anything. Okay, the result will not be shown. So to understand, to view the result, you have to click on the, you have to add some command. You have to tell to the computer that after analysis you have to show these things as a result. Okay, so you have to tell to the computer. The method is like that. You have to click on post analysis command. Click on post analysis command. Click on defined command. Click on the joint displacement. So if I want to know the joint displacement, click the joint displacement. Click the member force. Click on add. Click the support reaction. To add the support reaction, click the add, and okay, just do it. Now print joint displacement. Joint displacement, I want to know the amount of displacement at this point. So select the joint displacement. Now there is an assignment method. Use cursor to assign. Click on assign and select this node. Okay, now select again. Now click the member force. So the force of this member will be shown. Now assign this member. Okay, now support reaction, if you want to know, assign the support reaction of command to this support. Okay, now you just click on the run analysis. Click on save. Okay, so the analysis has performed, and you can see all the procedure here. You can see here 0 error, 0 warning, and 0 note, means there is no error and there is no any warning issue. So if you go to post processing, from here go to post processing mode and click done, click OK. Okay, you can see the joint displacement here. This is the joint displacement of node 2, and this is the joint displacement of node 1. You can see node 1 is the support. Okay, in the node 1 we apply the support. So if the support is present, then obviously the joint displacement will be 0. So all values are 0. Okay, and this is the free end. That's why some displacement will be created at this point. So this is the amount of displacement. Now if you want to see the reaction, you see this is the reaction in y direction, 20 is the reaction, and the moment will be 960. So if you click on a beam result, this is the result. Okay, so now if you want to know the shear force diagram, then click on Fy, shear force in y axis. Once you click, the shear force diagram will be shown. Okay, and if you want to know the bending moment, then you have to click on Mz. Okay, if you want to click, once you click the Mz button, then you can see the bending moment diagram here. So this is the procedure to analyze this simple beam, cantilever beam. Okay, now if you want to go back to the previous model, then you just click on analytical modeling. Click on analytical modeling and you just go to the previous background.